Hi everyone, welcome to the ultrasonic kit for Arduino tutorial series. Today we'll get to know an instrument, a voltmeter. By the name we can tell it is to measure the voltage. In this experiment, we're going to make a simple voltmeter and display its reading on an LCD. Now let's get started. First, let's look at the experimental phenomenon. We can see voltage value 5 volts displayed on the LCD in two lines. Now turn the potentiometer counterclockwise and the voltage decreases. Turn it clockwise and the reading increases. So you can adjust the voltage by the potentiometer. Here we use it to indicate that the measurement range is 0 to 5 volts. Now let's see what components we'll need in the experiment. The sun-founded Uno board, a breadboard, LCD1602, two potentiometers, one to adjust the resolution of LCD1602 and the other to regulate the voltage, a USB cable, and some jumper wires. Then the experimental principle. Connect the output pin of a potentiometer to pin A0 of the Uno board so as to convert analog signals into digital ones via the AD adapter in the board, and then display them through LCD1602. And use the other potentiometer and adjust the resolution of LCD1602. Now let's build a circuit. Hook up LCD1602 and two potentiometers to the breadboard, and then GND of the sun-founded Uno board to the breadboard. Hook up pin K of LCD1602 to GND. A to 3.3 volts. D7 to pin 13. D6 to pin 12. D5 to pin 11. D4 to pin 10. E to pin 6. RW to GND. And RS to pin 4. Then connect OV of LCD1602 to the middle pin of the pot on the left side you are facing. VDD to 5 volts. And VSS to GND. And connect one of the red pins of that pot to GND. Finally, hook up the middle pin of the other pot to A0. And of the rest two pins, one to GND and the other to VDD of LCD1602. Then open IDE and type in the code. First define the header file. Constant integer analog in equals to A0. Then we set the pin to connect to the pot, which is pin A0. Generally, the format is liquid crystal RS enable D4, D5, D6, D7. The liquid crystal statements we just mentioned in lesson 11. Here we use it to connect RS to pin 4, E, which is enabled, to pin 6, and D4 to D7 is hooked up to pin 10 to 13 respectively. Define the variable as value equals to 0. We also have talked about the data type float previously. Floating point numbers are often used to approximate analog and continuous values because they have greater resolution than integers. Here we set it as 0. The statement begin sets the data rate in bits per second, also baud, for serial data transmission. For communicating with the computer, use one of those rates such as 300, 9600, or 115,200. You can, however, specify other rates. For example, to communicate over pins 0 and 1 with a component that requires a particular baud rate. Here we set the speed as 9600 bits per second. Then set the position of the characters on the LCD as line 2, column 16. Print the character's voltage value on the LCD. Read the value of the potentiometer to val. You may recall we added a float statement previously. Convert data to the corresponding voltage value in a math way. Print the number of val on the serial monitor. Then print the units as V, short for voltage, on the serial monitor. Prints in prints data to the serial port as human-readable ASCII text, followed by a carriage return character, ASCII 13 or /R, and a new line character, ASCII 10 or /N. This command takes the same forms as serial.print. Then a line feed is added after the number and unit of the value on the serial monitor. The serial monitor is for simulation. Place the cursor at line 1, column 6. From here, the characters are to be displayed. Print the number of val on the LCD. Then print the unit as V, short for voltage, on the LCD. Wait for 200 milliseconds. Okay, the code part is finished. But you may have learned the statements well. If not, you may find some related knowledge to reinforce your understanding. Now connect the SunFounder Uno board with the computer and upload the sketch to the board. Then we can check the achievements. We can see voltage value 5 volts displayed on the LCD in 2 lines. Now turn the potentiometer counterclockwise and the voltage decreases. Turn it clockwise and the reading increases. So you can adjust the voltage by the potentiometer. Here we use it to indicate that the measurement range is 0 to 5 volts. So that's all for our experiment. Hope you've gained a lot from it. Actually, it is not limited to measuring the voltage of a potentiometer. You can replace it with any other device. Just complete the circuit and do the similar coding, and then you can make the LCD display the voltage for the device. When you have no multimeter at hand, it will be a great tool for you. Same as usual, come visit our website sunfounder.com for any questions or comments and leave us a message. Thanks for watching. See you next lesson.